Alrighty, so looks like I'm doing this a little late and I maybe have done this before. That's easy. Check if digits are equal in string after operations. 1. You're given a string S consisting of digits, but perform the following operation repeatedly till the string has exactly 2 digits. For each pair of consecutive digits in S, starting with the first digit, calculate a new digit as the sum of 2 digits modulo 10. Replace S with a sequence of newly calculated digits, maintain the order in which they are computed. Return true if the final 2 digits are the final 2 digits S are the same. So every consecutive pair of digits, it's going to do the sum of that mod 10, and then it's going to replace the current string with that until it goes down to 2 digits. So 3, 9 is 12, 12 mod 10 is 2, 9, 0 is 9, mod 10 is still 9, 0 plus 2 is 2, mod 10 is 2. So 292 is the replacement, and then iterating on that, 2 plus 9 is 11, mod 10 is 1, 9 plus 2 is 11, mod 10 is 1, and returns true because it's the same. So I think maybe the kind of simple, straightforward way, which would be just calculating each value of the string each time. So let me go ahead and convert the string into an array of digits. Digits is going to be, what was the syntax here? It's going to be the list based on mapping each string into an int. I think it's int. Is it s int or int s? I think it's probably s int. Let's just return false for the time being. Type is not iterable. Never mind. It's int s. So I map it. So it changes the characters in the string into integers and then converts those individual integers into a list. Okay. So maybe I can call it digits and next digits, or I'll just call it next digs. So n is the length of digits. If it's 4 originally, then there needs to be 2 iterations. 1 iteration, 2 iterations. So it'd be n minus 2 for k in range, n minus 2. Next digs. I guess that's the iteration. Each iteration needs to go through each index. So for index in range, and the indices are going to be n minus k. No, n minus k minus 1 because I need to access index and index plus 1. So next digits append the quantity that is the sum of digits at index plus digits at index plus 1, close parentheses, mod 10. So if n is 4, k goes from 0, k is the number of loops, the number of times you need to operate here. So this would be n minus 2. And then I need to go through the number of digits at in that iteration, subtracting 1 because it's going to be index plus 1. And the number of digits of the operation should be n minus k. Okay. And then after the for loop, I do next, or digits equals next digits. and then I just return whether digits of 0 equals digits of 1. Alright, so this should not work. Should not work. Do something wrong here. Let's go ahead and just print out what the next digits are each time. Oh boy. Next digits needs to be cleared at the start. Maybe I can just have it be blank at the start. Well, so it comes 292. I'm using append. Yeah, appending is not going to work if I leave it. If I kind of use the same array. So maybe I can use this to be 0 times n. It could maybe become times n minus 1, but I think I need to just say next digit at index. Okay, I think that might work, and that might be better in terms of memory. Unmatch parentheses. This summed mod 10. Local variable n. Undefined. Okay, I think that probably works. N equals length of digits. Whoops. Guess I could just say n equals the length of string. Alright, well that was simple enough. I think this is, I think there could be improvement here in terms of, I'm pretty sure there's an underlying structure of how the first and second digit of the final iteration is composed of some binomial distribution of the original digits. Like if I use a binomial distribution of 390 in terms of the binomial expansion being the coefficients of the 390. Like I think it's 1 times 2 times 9 times, or 1 times 3 plus 2 times 9 plus 1 times 0. Or 1, 2, 1 is the binomial coefficients for a plus b to the second. I think that gets you to the 1 here. 3 times 1 plus 9 times 2 is 18, so 21, 21, 1 plus 0 is 21, so that mod 10 is 1. And then 902, I think it's like 1 times 9 plus 0 times 2 plus 2 times 1. So it's 9 plus 2, which is 11, which is mod 10 is 1. So anyways, there's a maybe faster way of getting these digits without having to do kind of an n squared operation of things, but it's easy, and maybe that's the hard version or the medium version that I'm not solving right now. Summary. So use a nested for loop to, well, to make it easier, convert string, which is basically a char array, to integer array of digits. That's this first part, list of the mapping of integer to, or s to integers. And then after that, use a nested for loop to create the next iteration of the array slash string slash digits. Each iteration will the inner loop will iterate over the digits of the current array and determine the value at the corresponding index in the next iteration array. Do so until there are only 2 digits in the array. Return whether those two digits are the same. So this is case the outer loop, which goes through each kind of operation, and each operation will have an inner loop that goes through the indices, calculating the appropriate value, and just a small kind of technique to save space. You can kind of reuse the arrays in the memories of just 2 arrays to do that, as long as you kind of swap the memories afterwards. Time complexity, this can be O of n squared, since it uses a for loop, or a nested for loop, where both outside and outer and inner loops are based on n iterations. I am pretty darn sure that there is a more efficient algorithm based on directly calculating the final digits of the final iteration array based on some binomial calculation of the original array. But not necessary given these parameters, I guess. Or the parameters. Yeah, it's pretty short, like 100. Space complexity, this is going to be, I would say here, pretty sure there's a more efficient, more efficient. It'll probably be O of n, or O of n log n maybe. Shouldn't be sorting. Might just be O of n if it's more efficient. Space complexity is going to be O of n to have the temporary next array of digits, which is kind of swapped every iteration. Okay, cool beans. This might be even possible. Wow, I think maybe it's possible to do in place, right? I think it might be possible to do in place without that memory, because you're just changing the digits. Yeah, actually, so I think it might be like something like digits at index. Yeah. Because you don't actually use the prior index later on. Okay. Well, then it's going to be O1. To